Hi, good morning or good afternoon or evening, depending on what time of day you are watching this. Good to see you, class. Today we are going to be looking at lesson 1-A. We're going to be using powers to estimate quantities. Really what we're going to be doing is we are looking at scientific notation here, okay? So we're going to be looking at scientific notation. So we are going to be estimating very large and very small quantities by rounding and then writing that number as a single digit times the power of 10. So we're going to be rounding and we're going to be writing it as a power of 10. And writing it to a power of 10 means we will be using scientific notation. So scientific notation is a special way to write numbers, typically really big numbers or really small numbers, okay? So the way that we write scientific notation is, and this form is true for all notations or all numbers using scientific notation. We will have A times 10 to the power of n. And this A value has to be between 1, it could be 1, and A has to be smaller than 10. Okay? N must be an integer. Must be an integer. Okay? Meaning it has to be a positive or negative whole number. Okay? So let's look at some ways of writing scientific notation. So we could have a really big number. Let's say, I don't know, 2, 4, 5, 6, so 2,456,000. We can write this where A has to be between 1 and 10. So A will be 2.456. Okay, so this has to be between 1 and 10. And then we have our decimals here, and then we just count how many times did we move our decimal here. It's 1, 2, 3, 4, 5, 6. So we will take that times 10 to the power of 6. All right? Or we could have another one. Let's say we have 1, 4, 5. Let's just say 1,450. Typically, we wouldn't write this in scientific notation because that's not a really, really big number. But we could write that as 1.45 times 10 to the power of 1, 2, 3. So it's 3 places over. All right? Okay. Another way, let's say we have a really small number. So let's say we have 0.0000045. All right? This can be written the same way as 4.5. So notice, this is our A value. It's between 1 and 10. And then we have our decimal here. And then we just count how many times does the decimal have to go over. So 2, 3, 4, 5 times 10 to the power of negative 5. So if it's a really small number, our n value must be negative. Okay? So let me recount that, make sure I didn't miss that. 1, 2, 3, 4, 5. So it's negative 5. And I don't know why I have 2 different colors there. Didn't switch it. Keep it all the same color. All right, we could do one more. Let's say we have 0.000000004. All right, that's the same as 4 times 10 to the power of, so our decimals here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 to the power of negative 9. All right, so that is a little bit about scientific notation. Now we're going to use scientific notation to estimate large quantities. So Janelle here is going to estimate, Janelle is comparing the the estimated populations of Japan and China. The estimated population of Japan is 126,818,019. The estimated population of China is shown, okay, about 1.4 billion. How can Janelle compare the two quantities more easily? So the population of China, I'll write that down over here, is 1 billion to 402,941,487, and the population of Japan is 126,818,019. So we're wanting to compare these two. Since we're going to compare them, we are going to estimate. All right? So let's estimate this. We'll estimate this one to the closest billion. So this is about 1 billion. Okay? And the population of Japan is about 100 million. So we can write the population of China as about 1 times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9 to the power of 9. And the population of Japan is 1 times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8 to the power of 8. So we can see that Japan is about 10 times smaller, or China is about 10 times bigger than Japan. Okay, so we are going to count the zeros to determine the powers. So to compare the two, we can see that China is about 10 times larger. Okay? And the reason why we can say that is because our base, our A values, are the same, so we just have to see that it is 1/10 bigger, so it's 10 times larger. Okay? Go ahead and try this one on your own. So first you will need to estimate and then compare the two. All right. No, I don't have this one easy access. All right, I'll just have to check this one later. All right. Matthias used a laser to measure the average thickness of a human hair. A sheet of paper is about 0.0013 meters. Meters thick. How do the thicknesses compare? Okay, so we have the hair, which is right here. There's the hair. Oh, wait. And sheet of paper is about, so then we have the paper, and then we have a hair as well. So how do they compare? So the paper is about 1.3 times 10 to the power of 1, 2, 3, -3. And the hair is about 1.7763 times 10 to the power of -1, 2, 3, 4, -4. All right, to compare the two thicknesses, we can just say that the paper is about 1 times 10 to the -3. We're just going to round it. And the hair is about 2 times 10 to the power of -4. I'm just rounding this. Round up because 7 is above 5. Round down because the 3 is below the 5. Okay? So we can see, we can see that which one is bigger. So we can see that the paper, or the paper is 1 times 10 to the power of -3 is larger than 2 times 10 to the -4. Okay? So the hair is smaller than the paper. So find how many times as much. How does the gross domestic product, or GDP, of Canada compare to that of the United States? Since it uses the word compare, we are going to estimate, okay? So this, cut that off there. It says compare, okay? So the USA would be about, we're going to round this up, so it would be about 20, a lot of zeros here. Make sure we got them all. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Good, I got them all. Okay? All right? In Canada, Canada is about 2. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So I'm just rounding these, okay? So 1, so this is rounding up to 2, this one's rounding up to 20, okay? So we can write this as USA is 2 times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 10 to the power of 16. And Canada is 2 times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15. So we can see that the GDP of the USA is about 10 times more. USA is about 10 times more. All right, and I'm sorry, my face kind of got in the way here. Forget that my head's on the computer over there. All right, so, right, we can say that because the A values are both 2, so then we just look at the integers there. All right. Go ahead and do this one on your own. Compare the numbers of cars in the world to that in the U.S. So we're comparing, so you're estimating it and then comparing the two. Keep working hard. You're doing a great job. Please email me if you have any questions. Getting a lot of questions out there. If I don't respond right away, I'm sorry. I will try to respond as quickly as possible. High fives. Great job. Bye.